Hello friends, welcome to another tutorial in digital electronics. In the last tutorial we talked about 2's complement. We saw a trick to find 2's complement of a number in few seconds, and we are going to use that trick in an application of 2's complement, which is binary subtraction. Now the primary topic of discussion is binary subtraction, and we can do that using two different methods, and we can do that using 1's complement, and we can use a 2's complement. Now if you select to do binary subtraction using 1's complement, you need to follow this flow chart, and this is pretty easy. You just need to remember it once, and then you can apply it every time you do subtraction. The school of thought behind binary subtraction using these two methods is that we do not need another tool or another operation to perform subtraction. We can use subtraction using addition of two numbers. So we can just manipulate the numbers as 1's complements or 2's complements and then add those numbers. So there are no two different processes going on. Subtraction is not a different process in microprocessors or controllers, or in digital electronics. So subtraction is also performed via addition. So how is that done? We'll study in this tutorial. So that's the use of using these two methods, that eventually the microprocessor or a digital device has to perform addition and nothing else. So let's look at the two numbers here. Let's say we have a number A and a B, and we can perform two different operations on these two numbers. For example, we can perform A minus B and B minus A. So this becomes our case 1 and this becomes our case 2. Now just by looking at these two numbers, you know that this number is a decimal 13, right? And this number is a decimal 6. So A minus B should give us a result plus 7, and B minus A on the other hand should give us a result minus 7. So if you choose to select 1's complement as your method of binary subtraction, so what's the flow chart that you need to do? So in this particular case, A is our positive number and B is our negative number. So you need to write the positive number as it is. So I'll take up the case 1. So we write the positive number 1 1 0 1 as it is. So step number 1 is complete. And we need to write the negative number as its 1's complement. So B, which is our negative number here, because B is going to be subtracted from A, so B has a negative sign, so B is our negative number. We will write it as 1's complement, and writing B as 1's complement is pretty simple. So I'll invert all the bits. So simple. So two steps are done. You need to identify what the positive number is, write as it is. Identify what negative number is, write 1's complement of that, then you add it. So when we add it, we get a 0 and we get a 1, we get a 1 and we get a 0 with a carry 1. Now when you add and when you get a result, so this is our result, and you get some result and you'll get some carry. So if you get a carry, you follow this path, right? So is there a carry? Yes. Is there carry? No. So no means no carry is generated. You get a 0 here, but we've gotten a 1 here. Now what does that mean, getting a carry 1? You simply need to remember this, that whenever you get a carry 1, the result is going to be positive, and you simply need to add that carry to the result. So whenever you get this carry, you add it to the result and you get the final result as positive number. So you get a positive result as soon as you see a carry, you just conclude that this is going to be positive, and what is going to be the final result by adding that carry into the result that you get here, and the final result becomes this, which is of course plus 7. And by the way, we could have gotten 13 minus 6 as plus 7. On the contrary, if we take up the case 2, so that would have been 6 minus 13, right? In this case, we needed to write b as our first positive number as it is, so we write b as our positive number, so we write it as it is. And about a, we'll write this as the 1's complement, so it becomes a 0 0 1 0, and we add it. So when we add this, we get a 0 here, 1 and 1 0 with a carry 1, 1 and 1 0 with a carry 1, and the final carry is also 0. Now look at this. When we get a final carry 0, we follow this path. So we've gotten our result. Is there a carry? No. So when the final carry is 0, we do not get a carry, then the result is going to be negative for sure. You just keep in mind that the result is going to be negative. And how do you find that result? You just take 1's complement of that number, and that would be the final negative result. So you know that this is going to be some negative number. And how do you find that number? You just simply take 1's complement of the result, and this is what you need to remember. So 1's complement of this would be 0 1 1 1, which is of course 7 with a negative sign, and this would have given us minus 7 anyhow also. So some important things that you need to remember: when you get a carry, the result is going to be positive, but you add that carry to the result to get the final value of the result. But when you do not get a carry, you take 1's complement of the result only, and you do not take the 1's complement of the carry. That's the key point. Please commit this to the memory. Whenever you get a carry 0, you do not go on and take the 1's complement of this carry also, because the final result is going to be these 4 bits only. So take 1's complement of these 4 bits, and that's about it. This 0 could be thought of as, you know, a representative of a negative sign, because I told you that this path will give you a positive result and this path will give you a negative result. So this is super important to understand, that whenever we add, of course adding is simple because you write the positive number as it is, negative number 1's complement, add. So when you add, the rest of the things become a little complicated because you'll either get a carry or you won't. When you get a carry, the result is going to be positive, just that you need to add that carry to the result. And when you get a 0 or no carry, you need to take the 1's complement of the result and put it as a negative number. Of course, that will be a negative number as we see here. So that's been verified also by this these 2 cases. By the way, these are the only 2 cases we can get by 2 numbers. You know, one could be greater than the other, and that's how they are taken care of. And 2's complement is exactly similar. So what do? We take up the number once again. So A is 1 1 0 1, our B number. So B is 0 1 1 0. So the same case. So this is 13 in decimal, this is 6 in decimal. So the case 1 could be A minus B. The process remains the same, write the positive number as it is. So if A minus B is the case, we write the positive number, which is A, as it is, and we write the negative number as its 2's complement. So if you do not know how to find 2's complement in just few seconds, please watch my previous video. It's highly recommended. So we start writing the numbers from the left until we encounter a 1. So we've encountered a 1, and then we invert the rest of the numbers. This becomes 0 and this becomes 1. So this is the 2's complement. Alright, so once we have the 2's complement, we simply add it as the flowchart says. The third step is adding and getting a result. So let's add it. 1, 1, 1, and 0 with the 1 carry. So again, this is the algo is simple. If you get a carry, we know that this is going to be a positive result, and you simply remove the carry, and this result will be your final result. This is plus 7. So you know that subtracting 6 from 13 will give you a 7 with a plus sign. So this is pretty simple, because the last step, as we did in 1's complement, is skipped here because 2's complement already takes care of that carry by adding 1 to the 1's complement. So it's pretty logical, also understandable also. So one step is kind of removed. So this is a rather easier method of doing subtraction. So subtracting B from A. The other case could be, of course, subtracting A from B. So we write B as it is. So that's the key point. Write the positive number as it is and write the negative number as its 2's complement. So I'll write the 2's complement of the number, which will become, so I'll write down 1 as it is, starting from the left, and I've encountered 1 in the first place, so I'll invert the rest of them. This 0 becomes 1 and 0 and 0. So if I add it, it becomes 0 and 1 and 1, 0 and then 1 without a carry. So if I do not get a carry, I know the result is going to be negative for sure. And when the result is negative, I simply need to do a 2's complement of the result. And mind it, this is the result only, and I do the 2's complement of this. And doing a 2's complement is again easier. I'll write this 1 as it is. I've encountered 1 in the first position, so I'll invert the rest of them. Right. Okay, so this is my final result, and of course with a negative sign. So B minus A is again 6 minus 13 would have given me minus 7. So that's how you perform 1's and 2's complement subtraction, so which is binary subtraction. But the fact of the matter here is the device, the digital device, microprocessor or whatever that is only performing addition, and the only other thing that it is doing is, you know, converting the negative number into its 1's complement or 2's complement form. And I hope this tutorial was of help, and if you liked the video, give it a thumbs up, consider subscribing to the channel, and share this video as much as you can. And thank you for watching the video and following the channel. You have a great day ahead and a good life. Bye.